As we begin our study of algebra, we're going to be looking at how things in real life and just different types of numbers, how they form patterns. And with those patterns, we're going to actually be making predictions. And as we study those patterns, when our patterns are found, what we can do is actually fit them into different function families. So the first thing that we're going to be looking at when I'm talking about function families is exactly what is a function. So at the end of this lesson, you'll be able to determine whether a relation is a function. So let's jump right into the notes here. First of all, a function is a rule that establishes a relationship between two quantities, the input and the output. All right, just a couple notes and then we'll do lots of examples so you'll know exactly what I'm talking about. For each input, there is exactly one output, and that's going to be our standby reasoning for why is something a function. And more than one input can have the same output. So something is happening, something is forcing something else to have a pattern and then come up with some answers. So just as some examples that I can think of that actually work, you probably, when you visited, if you were in the cafeteria today, or if you went to any sort of restaurant at all, or you went to Meijer's or a store or anything like that, you probably didn't realize that you were entering a function, but actually you were, because there's a pattern between how many items that you buy and the prices that you're going to pay, or which items you buy and the price you have to pay. So what I'm going to do is just do a few examples. If you can think of the item as being the input and the price being the output, okay, what we're going to be looking at, we basically just need to make sure each item has exactly one price, and more than one item can have the same price. So let me just give you a couple examples. Let's say I went to Meijer and I'm just buying a few items. Item 1 that I put on the conveyor belt when I go to checkout costs $2. And then item 2 that was on my conveyor belt was $3.75. Item 3 was $5.20. So notice for each of these, every single item has exactly one price. It's not going to give me a choice when I go through there. This would not happen. Item 2 could not also be $3, because if I bought item number 2, it couldn't be $3.75 and $3. That would be faulty, or I'd tell the manager I want the lower price instead of the higher price. So that can't happen. So as soon as I enter this 2 into that situation, that would not be a function, because every item has to have exactly one price. Right now, I'm going to think about the dollar menu, and maybe it's $1.10 now or whatever, at McDonald's. You can think of, let's just go ahead, we're still going to be the item is my input, and the price will be my output. So let's say, it's getting close to Christmas time, so let's say I want to do an eggnog shake. So an eggnog shake might be $1. Well, actually, that would not be on the dollar menu. Let me think of some things that would be on the dollar menu. Let's say a small drink might be $1, and then I believe probably a hamburger would be $1, and small fries would probably be $1. I think a McChicken sandwich is $1. So you'll notice every item has exactly one price, so it meets that first definition, but you'll notice it is okay for some of the items to all have the same price. There's nothing wrong with that. So as we're looking through examples, what we'll be looking for is to make sure that every input does have one output, and that it's okay for more than one output to have the same input. So let's try some examples that don't look like that and see if we can figure it out. Right, the first one is if something is in tabular form, which means there's just a table, we're going to decide if something is a function or not, and we'll try to explain. So first one, we're going to look at my x and my y. My x is my input, and my y is my output. And if you want to think of this first one as being my item, and the second one being my price. Okay, item 0 is $3, item 1 is $1, item 3 is $5, and item 4 is $6. So every single item has one price, and so yes, we'd be fine. So on this one, when it says are the following functions, we're going to say yes, and then we have to explain, so must do. On this one, I would just say every input has exactly one output. All right, example 2, again, we can think of items in price or input-output. Item 0 is $3, item 2 is $7, item 3 is $2, and item 5 is also $7. So first of all, I'm going to look at each of these items are all different items and they have prices, so we should be all set with that. And then if I look at it, I'm going to maybe think, oh, that might be a trouble. Is it okay for item 2 and item 5 to both cost $7? Yes, it is, just thinking back to the dollar menu example. So once again, for this one, it's going to be a yes again, and then exactly the same explanation. Every input has exactly one output. All right, let's take a look at the third example. Item 1 is $7, item 3 is $8, item 4 is $9, and item 3 now is $10. So we've got a problem here, because I'm going to not be happy with this, because how can item 3 be $8 and that same item be $10? They have to make up their choice. So this is a big no, and the reason is 3 has 2 outputs. That is not okay. All right, let's try some things in contextual form. Contextual form would just be there's a situation. Are the following functions, and explain, right? Example 4 says you have $100 saved and plan to save $20 each month. You want to find the amount saved given the number of months you have been saving. So what we're going to do on this one, again, it's a lot easier if you have a table to tell whether something is a function or not. So I'm going to go ahead and make a table. We'll just do an X and a Y. And our X will be the number of months, and the Y will be how much money we've saved. So when I started, after no months, I have $100. After 1 month, since I'm saving $20 each month, I'll have $120. After 2 months, I'll have $130. After, $140, sorry. After 3 months, I'll have $160, and so forth. So I could just continue along. So you'll notice each item, each input has exactly one output, so we are fine on this one. So I'm going to say yes, and I'll just say every input has exactly one output. All right, example 5. A teacher makes a table that lists the student's first name, X, and the student's last name, Y, of each student in the class. And again, if we're given a situation, it's much easier if we make a table out of the information. Okay, it says the X is the student's first name. So let's come up with some. Let's see. We'll have Mary, and the Y is the student's last name. So let's say I have Mary Jones, Molly Crinkle, and John Smith. Okay, so I'm listing names quite nicely. Now what I want to think, is there a way, is it possible for me to list the same first name? Yes. Let's say I have John. I know lots of Johns. Let's say I have John Lee. All right, so now notice I have made this not a function because John has 2 different outputs. So if we can think of something that we could repeat the X's for and get a different Y, then this is not a function. So I'm going to say no, and I'm going to say a student could have the same first name but different last names. So that's what makes it not a function. All right, we're going to try one more type of situation, and these are in graphical form. So you're given a graph of something, are the following functions, and then explain. We are going to do something, and I'm going to write it down here, that's called the vertical line test. All right, and so when I do the vertical line test, basically what I'm doing, it's just testing, is does every input have exactly one output. So what we're going to be doing is, you'll see the black graph. I'm just going to start drawing vertical lines through. Vertical are just up and down, and I could draw more of those if I wanted to. And then I'm going to just draw a dot where my blue lines touched that graph. So they touched here, touched here, touched here. So you'll notice this vertical line touched 1 time. This vertical line touched 1 time. This vertical line touched 1 time. So this is a function because what it's showing is that every input only has 1 output. If the vertical line were to touch more than one time, then I'd be in trouble. So I'm going to say yes on this one. And this one, I can actually just say it passes the vertical line test. All right, the second one, we can still do the vertical line test, and I get to stop after drawing one vertical line, because if you'll notice, this vertical line goes through that function 2 times, and what that means is that this input has more than one output because it has 2 dots. So I'm going to say no on this one, and I can just say it does not pass the vertical line test, because the vertical line is only allowed to pass through 1 time. All right, now number 8, you might be tempted to connect the dots. We're not going to. Instead, we're just going to start drawing vertical lines through the dots that are on the paper. So if I draw vertical lines through each one of those dots, notice this line touches the dot just at one spot, this one touches the dot just at one spot, this line touches the dot just at one spot, and this one touches the dot just at one spot. So since each vertical line only touched 1 time, once again, we can say yes, and our reasoning again will be it passes the vertical line test. All right, so hopefully now you are somewhat familiar with what a function is and determining whether a relationship is a function or not.